Welcome to Chapter 5, Section 4, Sum and Difference Formulas. And in this section, we're going to use sum and difference formulas to evaluate trigonometric functions, verify identities, and solve trigonometric equations. So if you look at your trig identity sheet, on the right-hand side, you'll see a little section that says sum and difference formulas. And so these are the formulas we're going to use today. And one thing we also need to remember are our 5 special angles, and those angles in radians are 0, pi over 6, pi over 4, pi over 3, pi over 2, and those are our 5 angles. And if we want to look at these in degrees as well, this would be 0, this would be 30 degrees, this is 45 degrees, this is 60 degrees, and this is 90 degrees. Now, these are all of our reference angles, and we know what sine, cosine, tangent are exactly at all of these angles. So we're going to use those and these formulas to determine the exact value of sine, cosine, and tangent at some other angles that aren't within these 5. So let's look at an example. Let's look at what is the exact value of cosine of 75 degrees. Okay, so cosine of 75, well, we have to figure out, can we rewrite 75 as either a sum or difference of these 5 angles? Well, 75 can be written as the sum of 30 plus 45, so we can rewrite this as the cosine of the quantity 30 plus 45. And so then we look at our formula. Well, cosine, we're looking at cosine here, and we want plus. So this is saying when you have alpha, some angle alpha plus some other angle beta, then that's the same thing as cosine of 30 times cosine of 45 minus sine of 30 times sine of 45. And so we know what these are. Cosine of 30 is going to be radical 3 over 2. Cosine of 45 is radical 2 over 2. Sine of 30 is 1/2. And sine of 45 is radical 2 over 2. So we multiply these together, we get radical 6 over 4 minus radical 2 over 4. Or this is radical 6 minus radical 2 all over 4. And so the exact value of the cosine of 75 is radical 6 minus radical 2 over 4. Let's look at another one here. Let's deal with sine, and let's put it in radians. So let's say we want to evaluate sine of pi over 12. Now, pi over 12 is not one of our nice 5 angles, but we still want the exact form of sine of pi over 12. Up to this point, the only way to find this is just plugging in the calculator. So we have to write pi over 12 as either a sum or difference of our 5 angles. Well, if we look at pi over 3 minus pi over 4, that is pi over 12, because this gives us 4/12, this is 3/12, 4/12, minus 3/12 is 1/12. So we can rewrite this as sine of the quantity pi over 3 minus pi over 4. And we look at, okay, so we have sine, we have minus, so we're going to need this right here with a minus. So that's going to be sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. And so once again, we just go through and evaluate here, and we know sine of pi over 3 is radical 3 over 2, and this is radical 2 over 2, and cosine of pi over 3 is 1/2. This is radical 2 over 2 once again, and so we multiply and we actually get the same result as we did last time. And you might ask, well, wait a minute, does that mean that sine of pi over 12 is the same as cosine of 75? And in fact, it is. Those are equal. Okay, and we found those exact values based on the sum and difference formulas. We can also use these formulas to simplify expressions. For instance, let's say we have cosine of the quantity pi over 2 minus x. And we want to simplify this. Well, we look at cosine and we have minus here. So that's going to give us cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. And so if we look at this, well, what is cosine of pi over 2? Well, that's 0. So that's gone. 0 times cosine, that's gone as well. And what is sine of pi over 2? That's just 1. And so this simplifies to sine of x. And this is actually one of our cofunction formulas saying that cosine of pi over 2 minus x is equal to sine of x. So we've just confirmed one of our identities. But let's say we want to simplify something else, say like tangent of theta plus 3 pi. And we want to simplify this expression. Well, we have to look at tangent. Well, we have tangent and we're adding 2, so this is going to equal tangent of theta plus tangent of 3 pi all over 1 minus tangent of theta times tangent of 3 pi. Well, the theta is a variable, and so that's not going to change. But what is tangent of 3 pi? Well, tangent of 3 pi is 0, so this goes away to 0. And then this goes away to 0, and 0 times tangent theta is 0, and 1 minus 0 is 1. And so we're left with just tangent theta. So what this tells us is that we have tangent of the quantity theta plus 3 pi. That has no effect on it. We can still just take tangent of any theta. Whether we add 3 pi to it or not, it will not change its value. So you're going to practice some of this in class on Monday. And you're going to have a few assignments to look at, but if you would like to look at a few practice problems before you come into class, look on page 404. And I'd like you to try some of the first few problems in 1 through 6. All right, and then you're going to continue to practice this on Monday.